To imagine what has never been and give it form. To understand the hidden patterns and to share in the discovery. Canada's National Research Council deals in the energy of stars and lasers, the complexity of microchips and the elegant software of computers, the synthesis of living genes, and new ideas on plastics and immunology. Our subject is the universe, but our aim is to apply science for the benefit of Canadians. We look deep into space, keep the nation's physical standards, help fight cancer, and lead the world in the technology of cold oceans. Aerodynamics. The word means more than aircraft. It's a way of improving anything that moves through air, whether it's transport trucks or short takeoff and landing planes with high lift wings. The key concept is energy, going faster and farther for less. We're studying aerodynamics, not just to save energy, but to generate it. With the soft technology of giant power turbines for wind and moving water. These room-sized lasers probe a state of matter like our suns. If researchers can harness fusion, then we will have an unlimited source of energy for the future. Right now, you're looking at the brightest lamp in the world. This artificial sun, developed in Canada, helps set quality standards for the solar industry. If solar energy is to become a cost-effective option, it must be rugged and dependable. So we're also involved in designing the semiconductor films that make these solar panels more efficient. Tall buildings whip up violent winds. How can you make a downtown core more comfortable? Take a scale model, put it in a giant wind tunnel for simulation testing, and check your results in the real world. Only with hard data can you hope to design more livable cities. A Canadian's chance of death by fire is among the highest in the world. Our fire research helps cut the odds. The sea. It covers most of the earth. Canada has over 200,000 kilometers of ocean coastline and a huge resource-rich continental shelf. NRC hydraulics engineers study how the sea affects man-made structures. They simulate the ocean's weather, waves, and ice to predict what will happen to harbors, breakwaters, and offshore oil platforms, how to cope with shoreline erosion, and ways to harness the power of ocean tides. High voltage. Canada's immense electrical network is not easy to maintain. Power engineers must solve recurring problems. Cables wear out too soon. Equipment is hard to calibrate. Energy cannot be transmitted with needed efficiency. NRC is contributing to solutions, but first they must be understood. Communication is vital to our use of space. We're using this model to test an antenna's broadcast patterns before a space shuttle takes it into orbit. If transmission imbalances occur, a device called a hybrid transformer will instantly correct them. The antenna will be used in an experiment to study air movements in Earth's upper atmosphere. This, in turn, will increase our knowledge of how weather affects satellite communications. With the grace of balloons, with the intricacy of radar, and with the power of rockets, we're finding and analyzing information from high above the Earth. The faint spectrum of a galaxy millions of light years away reveals its distance, velocity, and age. Other spectral effects indicate black holes whose gravity traps even light. NRC radio astronomers have found the heaviest molecules yet detected between the stars. And we are partners with France and Hawaii in one of the world's finest optical telescopes. What astronomers see is violent beauty. But what they learn points back to the moment of creation. A second infinity exists within. These red blood cells contain a substance that blunts the damaging effects of air pollution and drugs. Natural vitamin E. Researchers are involved in understanding how this key vitamin works. While laser chemistry, a hybrid of chemistry and physics, makes many chemical reactions faster and more complete. Using visible lasers, our chemists have developed a process that creates vitamin D. The technique has recently been transferred to industry. Similar methods using infrared lasers separate other useful chemicals. Other chemists examine metal corrosion, textiles, and cleaner ways of burning coal. Cancer. NRC is part of a worldwide research effort to find a cure. Our cell biologists have discovered a cancer-associated protein called oncomodulin, which could become a reliable early warning signal. Beyond our imagining 10 years ago, biotechnology may rearrange our world. The techniques are elegant. By altering the genetic form of a harmless microorganism, you can cause it to produce new substances, such as insulin and interferon. We are greatly expanding our research facilities in biotechnology to help Canadian companies apply these new methods to resource and manufacturing industries and pharmaceutical production. Incorporating such new technology is vital if Canada is to compete successfully in world markets. Immunology. In an ultra-sterile containment facility, our biologists are improving ways of diagnosing disease and perfecting new vaccines for serious infections like spinal meningitis. Marine engineering. Our northern seas are both a challenge and a threat to anything that sails on them, from fishing boats to supertankers. Icebergs can gouge and crush the thickest hulls. Giant waves and gale-force winds can tax the stability of even the largest vessels. Our engineers are working to make the ships that navigate these cold waters more efficient, maneuverable, and safe. Computer-aided learning, information science, and computer-aided design are areas of intense activity at NRC. Whether it's a sleek ocean racer or the champagne glass to toast its first victory, computers play a critical role in the industrial design process. So our programmers are teaching machines new ways of recognizing shapes and manipulating them in the real world. Automated machines are opening a multi-billion-dollar industry in which Canada can share. We're building new facilities to study and develop materials engineering, manufacturing technology, and robotics. And machine vision is one of the keys. NRC engineers have perfected a vision system like no other in the world. It can actually identify and track a moving object in 3 dimensions, just as our own eyes do. A Canadian company is putting it to work in heavy industry, and it will go into orbit as the eyes of the Space Shuttle and Canadarm. The National Research Council is physics and biology, chemistry and engineering. But more than that, it's dedication, imagination, and discovery.